Welcome to this new section where we will focus on a new category of tools that Alteryx offers, known as join tools. Now, join tools span multiple capabilities, but they all have one thing in common. They all, in some form or another, add data to data, meaning that we can take data from one dataset and combine it with another dataset to make one dataset. Now we'll be exploring 4 fundamental join tools, which are used frequently in data transformation, and these are join, union, find and replace, and append fields. So let's get started. The first tool we're going to observe is the join tool. Now the join tool enables us to join 2 incoming datasets together in a very similar way to how you would join 2 tables in an SQL statement, if SQL is something you are familiar with. If you are not familiar, let me quickly outline what I mean. Now, data is usually stored with a concept of relation. For example, you may have a database that hosts data for a retail store. One table may pertain to customer information, which has items like customer ID, name, address, and telephone number. You may then have another table which shows sales, which has information like sales ID, customer ID, and purchase date. Now, despite this information residing in 2 different tables, we are able to obtain information pertaining to a specific customer and ascertain whether they have purchased anything by observing the customer ID column in the sales table, and then referencing the same customer ID in the customer table to bring back information such as their name and address. Now, we can join many different datasets together across disparate data sources. For example, we can join data that is stored in a database to data that is maintained in Excel or a CSV file. We can join data across different databases such as Oracle and a MySQL database. Wherever data resides, we are able to join it together providing there is a common element, otherwise known as a joining field, which we will explore shortly. So we'll cover 4 common join types known as the inner join, left join, right join, and the full outer join. Now, the syntax required to construct these join types is very similar, but it's more important to understand the concept of each join and the result each join type will produce. So firstly, we have the inner join. The inner join will retrieve rows from both tables, providing there is a match between the joining fields. If there is no match between the tables, the rows of data from both tables will be omitted from the output. This is represented by the blue segment in the Venn diagram. So let's take an example of 2 tables. On the left we have a small employee table which consists of 10 employees, and we're provided with the emp ID, full name and hire date. In the table on the right we have information regarding each employee's salary. The fields available are emp ID, prior salary and current salary. Now, by performing an inner join on these tables, we will get back a result where we have matching emp IDs, as emp ID is the field we would use to link these 2 tables together. These joining fields are also known as keys, and we'll cover primary and foreign keys in more detail later in this section. So as you can see, as both tables have emp IDs 2, 4, 6, 8 and 10, these are the only values we obtain in our output once the join has been performed. This means we are now able to see what the prior and current salaries are for each employee alongside the full name and the hire date in one single table. Now, when we perform a left join, the result we obtain will take all information in the left table and it will be enriched with information from the right table if there is a match within the emp ID column. If there is not a match, then the columns from the right table will be populated with null values like so. So here you can see we have all data from the left table, and we now have information from the right table where there was a match in emp ID. Where there is not a match, the right table values have been populated with null. Now the right join is essentially the same as the left join. However, this time we have a result where all information from the right table will be present and will be enriched with information from the left table where there is a match in emp ID. Any rows that do not match will result in values from the left table being populated with null. So the result will look something like this, where you can see all data from the right table, and where there is not a match, the values in the left table columns are populated with null. And finally we have the full outer join. Now this result brings back all data from both tables. And where there is a matching value within the joining field, information from both tables will appear on a single row. Where there is not a match, information from the left table will appear alongside null values from the right table, and information from the right table will appear alongside nulls from the left table. So hopefully that provides some useful insight, or in some cases a refresher, on join types. In the next video, we will see practical applications of the join tool in Alteryx and cover the configuration options available.